Hello, hello, and here we are. I am Justin Garrison
Hello.
and joined with Sheetal and Alex's cat.
Hey, yes. Good to see everyone again. Thank you, folks, for helping us and partnering with us today on talking about IPv6.
Is that a cat 6 or cat 7? I don't know if that's
She's the IPv6 cat and the inspiration for our t-shirts for today. So yeah, we're very much V6 cats.
awesome. So
Yeah.
welcome to Containers from the Couch. Anyone that's new to the show, we have a regular show every week about containers, any container service on Amazon, using containers for various things, a lot of open source and different things. But today, obviously, we're talking about how containers and IPv6 work together, and specifically how EKS and Kubernetes works with containers. So joining me today, like I said, is Alex, who you've already been seeing on the streams, and welcome Sheetal, who's a regular on the show, and an awesome networking person that I asked a lot of questions to. So thanks for joining.
Yeah, and I guess I'm very excited to share the screen space with Alex today, and want to know whatever she has to teach us. Yeah.
Oh, I think it's gonna be more about me learning about containers and IPv6 and how they work. So I'm gonna make use of this time, Sheetal, to actually learn from you. I'm gonna ask you a lot of questions of how things work, and hopefully we'll do some whiteboarding here so that everyone on the stream is also going to learn together with me how all things work and how they can use IPv6 with pods and Kubernetes and EKS.
I guess we are going to use a little bit different, try out some different techniques today for this session, Justin.
Yeah,
Typically,
I mean, I love a good whiteboard. If you can draw
yeah,
me a picture, I'm gonna understand it a lot more than you just telling me something. So let's go ahead and dive into that. Want to?
cool. Yeah.
Awesome.
I guess
Yeah.
I'm going to bring on, yeah, there you go, Alex.
Awesome, awesome. Oh, we had an AWS banner there on the whiteboard. So yeah, I did a bit of pre-work here so that not everything looks like a very modern work of art that no one understands. So I've already created my Amazon VPC. I have my Amazon VPC on IPv4. Folks on the stream, don't get scared. We're going to talk about IPv6, not IPv4, right? So but I'm starting with my VPC. My VPC is IPv4. I have my private subnets. I have my public subnets. And obviously, I started with the IP space that everyone uses in their VPCs, 10.100/16.
It's the best subnet.
Um, it is the best. Absolutely the best, and it overlaps with everyone. So that's going to be a very, very good use case for you to actually start adopting IPv6. The other thing that I did here is I've chosen this very, very big IP space for one reason, which is very important. And Sheetal can probably add more color here, but EKS and containers, specifically Kubernetes, are very hungry for IP addresses. And when we create clusters in the VPC, and here's my second very nicely drawn diagram of my IPv4 EKS cluster deployed in my VPC across my two subnets. The pods and worker nodes, pods specifically or especially, consume a lot of IPv4 addresses.
Well,
Why
IPs are
is
free,
that?
right? Why wouldn't they? It's just like you just throwing them out like candy. Let's all have an IP address.
Yeah,
Like
yeah,
Oprah out
yeah,
there in the network just giving out IPs.
I mean, we have a
exactly.
choice, right? Like typically in Kubernetes, pod networking is handled through a CNI. And we use Amazon VPC CNI, which is like VPC is the best battle tested layer 3 network that's out there. And we wanted to leverage all of the cool benefits and the features that VPC can give us. And we implemented a CNI in an underlay mode. And in an underlay mode, we assign IP addresses from the VPC header directly to the pods, which kind of gives us a lot of benefits if you think it's like directly integrated into the VPC fabrics. There is no overlay, there is no tunneling, and you can also get the cool features of the VPC, like integrate with the flow logs, right? So all of those such cool things. But then again comes the challenge that all of these pods require an IP from your VPC CIDR range, right? So
Yeah.
I guess Alex is going to draw some of these things, which will kind of make clear.
Yep. So I think first, one of the things that we're gonna start looking at is these pods that I have here on my worker node have IP addresses. You can see that they have actually IP addresses from the same subnet CIDR. You can select multiple subnets in your VPC. You don't have to have just 2 or 3 or how many AZs you have. And whenever pods come up or are spun up or get spun down, they get IP addresses from the subnets. They release them. So here's where the challenge comes, right? And I think I've been in so many calls with so many customers saying, how do I extend my IPv4 space, right? Can I use, for example, a secondary CIDR on the VPC from the non-routed space? So we have a lot of customers who've done actually this, and they've started adding 100.64.00/16, for example, and they started not routing this CIDR, and these pods here would have IP addresses from the 100.64. But there's so much more. There's so much that you can expand a very finite set of IPv4 addresses. So here's where the interesting part comes into play. We've started to sort of optimize this allocation with the idea of prefix delegation or subnet CIDR assignments, which essentially made use in IPv4. Let me draw this one out here. This worker node had an ENI, right? This is ENI 1, let's say. And to this ENI, we would assign a prefix, a /28, out of the subnet CIDR space. So let's say that we have, 10, 1, what do I want to say here? 0, 64/128. Let's make it nicer here. 64/28. And this prefix was used for address assignments from it to pods, right? So you can sort of optimize there. You can optimize the API calls for spinning up and spinning down containers and so on, or pods. But still, this consumes IP addresses, right?
And that's not the default, right? In Kubernetes, this is an optional to do prefix assignment.
So CNI in a default mode works in something what we call a secondary IP mode. So CNI itself runs as a daemon set on a worker node. It has 2 components: a CNI binary, which concerns itself with assigning an IP address, and when the pod comes up, right, and the pod is deleted, it just deassigns. But there is another module which is called as an IPAMD, which is kind of running in the background. What it does is, you see the ENIs on the right hand side, it kind of assigns the primary ENI, when the comes up, assigns the secondary IPs for those ENIs, keeps what we call it as warm pool of IPs, and the ENI is ready. So typically a default setting is warm ENI target as 1. You see primary ENI, and also you see as a secondary ENI that is assigned on a node 2. So as soon as you try to schedule a pod, the request goes to API server, API sends it to scheduler sees, okay, this node is eligible to schedule a pod, and the API server makes a call to kubelet then says, okay, let me invoke CRI makes a call to CNI, and then pod comes up, it assigns an IP address, and in the backend, IPAMD, which is running, okay, now I have 4 pods, say a secondary IP limits on that ENI is 3, so it has already created a secondary ENI and created a warm pool of IPs so that the pod launches are faster, right? You do not have to wait for the pod to come up, waiting for an IP to be made available for you. So that's the IPAMD. And prefix delegation is not enabled by default. And here, if you see in a secondary IP mode, what happens is you're kind of limited by the number of secondary ENIs that are available for an instance. But in a prefix, you can just actually maximize the number of the pods that you can actually deploy on a worker node by assigning a prefix in place of a secondary IP. Yeah, that's the biggest benefit of the prefix delegation. However, it's just a cool feature to kind of solve the pod density issues that some of our customers have on a larger instances, but in no way it's going to solve an IPv4 exhaustion on your cluster. Yeah.
Yep. Sheetal, do we want to talk a bit about the ingress egress patterns from my EKS cluster here, just to make sure everyone's on the same page?
Yeah. So I think what Alex has is here is two public subnets, and you kind of see she has the elastic load balancers, right? So it is basically if you want to ingress into the cluster itself, and Justin can chime in too here, right? So you create a Kubernetes service or an ingress. We have something called as Elastic Load Balancer Controller. It integrates with the ELB. And when you create a ingress type, it creates like application load balancer. And typically you ingress into the cluster via one of these ELBs, right? And similarly, when you create a Kubernetes service type, it creates a network load balancer for you. Yeah. So Alex from outside, from internet, she's trying to access one of the pods behind a Kubernetes service, and which is kind of behind ELB, NLB or an ELB here. Yeah.
Nice. So I can do this from outside with the public facing load balancer. I can do this from within the VPC with the same or an internal load balancer. I can do this from my private network if I have transit gateways or VPC peering and all of that. I can use this ingress mode with the load balancers. Cool. Okay, so things start to become more clear for me with EKS and networking on IPv4. But how do we get to IPv6? Or why do we get to IPv6 first and foremost?
Yeah, you start to schedule pods like, 1,000, 10,000 pods, and your application actually become IP hungry, and you get into an IPv4 exhaustion mode. And okay, you bring in the CGNAT space, start assigning the secondary siders. But sometimes, and many of our customers have complained that we have already exhausted even the secondary siders that we can assign to our VPC, right? There is no more non-routable siders that we can assign. It has already been consumed, so we are out of the options. Like secondary cider, when you assign, there is something called as custom networking that we kind of support today. Like pods, as you draw in the previous address, can receive an IP address from the secondary ciders, which is from a CGNAT space. But that also is like a non-routable space. And then when you have the overlapping CIDRs and all of this transit gateway and all of the complications that probably Alex can talk in length and depth for hours together, those challenges still exist. And that's where the biggest motivation for EKS to support IPv6, right? So unlike upstream Kubernetes, where dual stack is supported, we did not go with that route, because even if we had supported in a dual stack mode, we wouldn't have solved an IPv4 exhaustion problem, because we still integrate with the VPCs, and pods will have still gotten an IPv4 address from the CIDR space. We wouldn't have solved the IPv4 exhaustion problems. Instead, we went with single stack IPv6, but we support dual stack ingress and egress into the cluster itself.
We'll get there. I think there's one question that is not being asked, but I think I've been asked this question so many times in the past couple of months, years. What about overlay? Like, why shouldn't I, or should I actually start thinking about having a CNI that provides me with overlay functions so that pods are native at the worker node level? Why shouldn't I go for that?
So in an overlay mode, right? Yeah, of course, your container IP range is independent of the host IP range. But what happens during the communication, even across the pods, you kind of create a tunnel, right? So when there is a tunnel, there is capsulation and encapsulation of the packet that is involved. And you also kind of lose the benefits of observing into the network itself, which an underlay mode provides today. And over this capsulation and encapsulation also kind of adds a overhead, right? And we wanted to kind of avoid all of that and then go with the underlay mode to kind of provide all the benefits of VPC and I provides today.
Yeah. And I think like this question always comes with, okay, so if I go with overlay mode, can I still use VPC flow logs and see all the information? How do I actually track into every single IP address on the overlay that what it does? How do I implement security for those and so on? So it's at a bit of overhead that gets added there because of the overlay mode, the lack of visibility, as you mentioned.
And I think one of the big things is like you solve one problem, introduce more, because you create a new network on top of your network, and you have to reintroduce all those tools that the network is already, the VPC subnets are already doing for you with gateways and flow logs and all that information. Now you're like, oh, I just want a new network. I just want to get away from that network, create this new one. It's like, that's fine. But how are you going to re-implement all those things that the network gives you at this new layer in that encapsulation? Because I can get VPC flow logs with an overlay network, but only at the host-to-host layer. I don't know. I lose all my insight into the pod networking side of it. And yeah, you just build another layer on top of it to avoid one problem, introducing, I now have duplication of what was happening at my network layer.
And here pods are like first class citizen, right? They just get the same IP addresses as the VPC and you get the clear visibility. I mean, we have some of our customers who are using overlay CNIs today, right? Cilium or Calico. Mm-hmm. And they understand pros and cons, and there are reasons that they wanted to go with this overlay choice, and they are perfectly fine. But majority of our customers, it wouldn't be wrong if I say like 98% of our customers just use VPC CNI out of the box. They just get benefits and also kind of integrate with all of the security features like VPC CNI provides today, security groups, right? So you can say there is another option that VPC CNI provides, security groups for pods. So whoever has liking the security group features, they are like, okay, I just want to enable the SGPP, right? Like security groups for pods. I just love, because that's how our networking team is laid out, and it just perfectly fits with our infra teams and the network ops. So we just kind of happy with the VPCCNI and all of the other benefits that just comes with it.
Yeah. Cool. Okay. So you've convinced me. I need to go to IPv6. Yeah. And I think we've convinced everyone here on the show that they do have to start exploring it. Now, we get to IPv6. I think the first thing that's very important, and we get asked so many times, is, how do I get started with this, right? Will the fact that I add a v6 CIDR to my VPC break my EKS cluster? The answer is no, it won't. You add the CIDR. Here's my diagram where I retrofitted my VPC to support IPv6, to have IPv6 CIDRs associated to it. So I have a v6 CIDR associated with the VPC. I have v6 CIDRs associated to my subnets. And I still have my v4 cluster. It's there. It's fine. I didn't do anything with it. It still works. And it continues to perform its duties. Now, what do I need to do to get my IPv6 into EKS?
Yeah, you have your VPC, which is a dual stack now. You have the subnets. You just say, okay, I want to create a cluster and say IPv6 as my IP family. That's how you start. No major lift and shift. And one thing to note, yes, we do not support in-place upgrades. You cannot just go ahead and click say, okay, I want to convert my IPv4 into an IPv6 today, but you'll have to start from a brand new cluster and specify IP family as IPv6, right? Everything else remains same. You just say, okay, I want to create an IPv6 cluster. All of the networking requirements, the prerequisites that we have, okay, you need to provide 2 subnets while you create a cluster. All of those things remain the same. You just go ahead and say, okay, I want an IPv6 cluster now. Yeah.
Awesome. Okay, so I've created my IPv6 cluster. Now my worker nodes that I've had, that I have to deploy here. Let me actually copy one nice worker node from here. The magic of diagramming. Okay, let me put it here. Let me make it a bit smaller, and we're going to be zooming in. Okay, so my worker node, let's clean up its v6. Oh, too much cleanup. Clean up its v6 IP addresses. Now, my worker node has an ENI, right?
Correct.
I start with that. What is the IP address of this ENI?
So this is the primary ENI. So worker node gets both IPv4 as well as an IPv6 address to begin with, right? So that's your primary IPv4 and IPv6 address.
Perfect. Okay, so my worker node is dual stack. That's great. I can still SSH into it if I want to. From my IPv4 world, we've heard this in an earlier session. Like, can I still SSH into my stuff with v4? Yes, yes, you can. So that's perfect. My primary ENI has v4 and v6, and now I have the pods. How does this work now?
So VPC CNI, right? So the first thing that comes up is a VPC CNI on that node. And again, the core functionality of the CNI do not change. Just in an IPv6 world, what happens is instead of basically, we talked about the prefix delegation in IPv4, right? VPC CNI kind of extend the prefix delegation functionality here. And the IPAMD of the VPC CNI comes in and say, okay, I want to basically start assigning pods an IPv6 address from the prefix. So it just goes ahead and assigns a /AT prefix to this primary ENI. So this is different. Like in IPv4, you will have a multiple ENIs to accommodate your pod needs. But here, the /AT prefix, IPv6 prefix is so huge, you will run out of your resources before you run out of a /AT IPv6 prefix, right? So it's just 10 to the power of 14. So it's like you have enough IP addresses here. So that's the first thing that happens, right? And pod come up. Pod will receive an IPv6 address from this /AT prefix. So both the pods.
Cool. Okay, so it has an IPv6 address.
Yeah, and interesting.
By the way, this is address for everyone who's asking themselves, why am I putting that? It's much easier than writing 128 bits in an IPv6 address.
Yeah. Colon. So what happens? Like, why do we need? I think you might ask a question, Alex. Why do we still need an IPv4 address to my worker node, right?
Oh yes. The network engineer in me is like, wait, so I have my dual stack worker node, but my v6 only pod. So there has to be something very important there in my traffic flows. Because the first thing that I'm asking myself is, well, how do I accommodate for my traffic flows, right? These pods need to talk to each other. And whenever I get the EKS cluster management folks talking to me and asking me, well, how will these work? I have to know. So
I think another question is like, you still require an IPv4 address to a worker node, then how are you solving an IPv4 exhaustion problem, right? It's like you do not need an IPv4 address from a VPC to your pods. Just the worker nodes needs an IPv4. And the reason we want, like, Holy Grail, North Star, everything to be IPv6, but we just have to understand not everything is IPv6 today, right? It's a journey that we are taking towards, and also our customers are taking towards, but it's going to take time. And still there are services, there are on-prem networks which are still IPv4, even some of the AWS services. So we want to provide an IPv4 egress capability for the applications that are running within an IPv6 cluster. By application means the pods. So that's where we need an IPv4 cluster. But how are we solving the egress from the pod itself, right? So VPC CNI, what EKS kind of does it. I mean, if you look at VPC itself, we have NAT64 and the DNS64 capabilities. We could have relied on the NAT64 and DNS64 and said all of the pod IPv4, just NAT it to a primary IPv4 address, and then use leverage the NAT64 and the DNS64. I think when we started to build IPv6, NAT64 and DNS64 was not a thing yet. So what we have done, went ahead and implemented a host local IPv4 CNI as a chained plugin to the main VPC CNI. So what that does is basically assigns an IPv4 address to a pod as well. But these IPv4 addresses are not from the VPC CIDR range, right? These are just the host local 169.254 range that gets assigned to the pod. So what happens when a pod tries to connect to an IPv4 endpoint? It uses the pod IPv4 address, right? And leaves the worker node NATed to the primary IPv4 address of the worker node itself. Depending on whether your worker node is on a private subnet or a public subnet, the routes are taken accordingly then, right? So you have the NAT gateway. Yeah.
Take me easy, Sheetal. Take me a bit easy. So let me see if I understand this, right? Because
Sure.
I want to make sure that I grasp this. So we've looked at the fact that my pod gets an IPv6 address from the /80 of my the prefix assigned to the ENI. Now, if we look at communication flows, this is what I get. I think I understand this, like two pods communicating to each other on this worker node.
Yes.
They go on V6 because it's super simple. They already have both IPv6 addresses. So why wouldn't they? That's fine. Perfect. So let me see if I understand this correctly. If I duplicate this, let's say I have another worker node, and the fact is that I don't have enough real estate here on my diagram to actually do another worker node in the same subnet, but it's the same thing. It's like a subnet and another AZ should be the same thing. So let's do it onto here. So if I zoom in here and I say, okay, what if this pod, let's say that this is pod 5, not pod 5, pod 3 and pod 4. And my pod 3 wants to talk, let's say, to this pod here. Not this one, but this one. Like pod-to-pod communication between pods in the same cluster or cross-cluster, could it be? It happens on V6 as well, right? So it's the same thing.
V6, yeah.
V6.
Yeah.
Perfect.
You
okay, so I
kind of
still use V6.
Yeah, because we also assign an IPv4, it's completely blocked. You cannot, just the rules that are configured on node, it just drops any IPv4 communication across the pods. It's just not allowed. It's always an IPv6 across the pods on the same node, across the pod on a different worker node, doesn't matter. Everything is IPv6.
Yes, perfect. Okay, so we're talking V6. Is this the same thing if communication goes outside the cluster? So let's say that I have an EC2 instance here, maybe, or whatever service that has IPv6 address assigned to it.
Or maybe
my communication.
Like RDS database, which is kind of a dual stack, or whether it's an IPv6.
Nice. Yes, perfect. So this is V6 as well. RDS does support dual stack. So recent launch. Folks, check it out. Awesome. So far, my flows on V6 are fine, but I start to get worried when I go back to IPv4, right? Because you mentioned that not everything is on IPv6. We still have to have that backwards compatibility. So let me actually duplicate this, because I have a feeling that we're going to be exporting this and making it available maybe on our routing loop page so that everyone has the flow. Or we should actually write a blog about it. So what you were saying is, right now I want to make sure that I have some kind of backwards compatibility with things that are on V4, right? So let's say that I have something here that is IPv4 service or something that I need to access. And we're going to see, actually, that's a very good use case for EKS itself as well. The question is, well, how do I talk between this pod and this thing, right? So here's where that additional IPv4 address that gets assigned to my pods that is non-routable, it's a link local IPv4 address,
correct,
comes into play. So my pods are actually going to have this, if I understand it right. It's going to have an IPv6 address, and it's going to have a 169.254.11.5, let's say. And this one is going to have an IPv6 address plus 169.254.11.7. Does that sound right? Do we use a specific CIDR in EKS for assigning these IP addresses?
Yeah, it's a static on all of the worker nodes, so basically both the pods can have 11.5, 11.5s.
Oh, cool.
On each node, right? Because they're not routable, so it doesn't really matter. You just keep the same IPs over and over again.
Oh, that's so nice. Okay, perfect. I think there's a cool question there from Carlos, and you're out in EKS, it's IPv6 from another VPC. We can talk about, we have a session actually later today talking about VPC lattice and how you can use it with IPv6 to either migrate or to integrate and to get all the things on your network using VPC lattice and application networking. Super, super interesting. So do please, I'm going to take the opportunity here to actually paste again our schedule in the chat. So if you folks go to that page, you're going to see our full day schedule for all things on IPv6 today. So back to our pods here.
Yeah, and we use 169, 254, 172 across all of the worker nodes. Yeah, /22.
Okay, perfect. So it's /22. Give me a second because my eraser here is a bit big for what I need to erase. So which one? Say that again to make it actually proper here. 172. Perfect. Awesome. Cool. So I have my EKS bot. It has an IPv6 address. It has an IPv4 address. So it wants to talk to this IPv4 resource. What happens at that time?
So pod 1 wants to connect to an IPv4 service 1. So it initiates the communicate. Basically, maybe say it's like a domain name, right? It just gets installed and then it leaves the worker node, NATed to a primary IPv4 address of the worker node, primary ENI, right? Because we are still in a VPC, we are not going outside of the VPC yet. So
correct. 1725 an IP destination. Let's say that my IP service here has I don't know which subnet are we on? 10.132.57. So here I have 10.132.57. Cool, but this is not enough because this ENI here, we said that the 169 are not routable, right? So we're not routing them anywhere, so we wouldn't be able to actually get to that service. There's another set that happens here when the packet leaves the interface, right? And there's another NAT. 10, the IPv4 address of the ENI.
So this is 20, yeah, 10.
Let's say it's 10.1.0.22, whatever IP address I had there. And IP destination is 10.1.32.57. Awesome. Okay, so I think I get it. This is great. And the return traffic. Oh,
just a question from the chat here about latency. Is there any impact on this repeated natting here from IPv4 to, or IPv6 pod to an IPv4 address versus going directly IPv6 to IPv6? Is there any performance penalty?
The question is pod 1 pings pod 2. So pod 1 pings to pod 2 is always via IPv6. It's never via IPv4. What we are talking about is an IPv4 service, which is maybe you might be running an EKS cluster there in that, that IPv4 service might be a application running within an EKS cluster. But pod to pod within the same cluster is always an IPv6. Yeah.
And same thing with a IPv4 cluster, it's always IPv4. So in both those cases, there's no additional overhead. What about in this case where I'm going from an IPv6 pod to an IPv4 address externally? If I was connecting to RDS, would there be any performance penalty if I switch that RDS to IPv6 or I leave it IPv4?
So IPv6, you get benefits of no natting, reverse natting, anything, right? There is no NAT happening here. And that's what one of the core benefits of using IPv6, because all of this complex natting is all taken away. Because every IPv6 address is kind of a routable, and because you're within a single VPC and there is nothing, it's just like plain transfer to another IPv6 address. Yeah.
Yeah, I mean, those NATs are local to the IP tables, basically. So you'd have to really have some high performance needs to feel any impact there. But I do think there's a lot of benefit in the troubleshooting side of that, where you're not losing that IP address as you're trying to NAT lower and lower into those layers, right? So I could say, this was my source IP, that's the pod that has the IP address, right?
Yeah. Also, super important, and it's the same thing that we were talking about a bit earlier in the session when we talked about NAT64. NAT64 is a function of how much V6 you are adopting. Like the more V6 services you have and the more you get your infrastructure up to speed on V6 and access gets on V6, the less NATing you're going to be doing. So here, this pod here, as we looked at this flow, the pod has v6, the service has v6. It's all good. It works on v6. No NAT happens.
Yeah, I think this is an interesting question. I think probably we'll be talking about in a couple of packets after we have. Can the control be IPv4? And yeah, so EKS, the Kubernetes control plane, which is managed by us, is IPv4 today. It's not end-to-end IPv6. We are working towards that, but it is IPv4. And I think we have another diagram where we'll talk about how does the control plane communication happens when the control plane itself is IPv4. We will just kind of finish this IPv4 and the IPv6 egress and ingress patterns, and we'll come to that question.
Yep. Stay tuned. 2 minutes, hopefully. So we've seen these flows from the pod to an IPv4 only service, from a pod to another pod on v6, from a pod on v6 to an IPv6 service outside of EKS. How do we do with the ingress piece? Because that's what I'm also curious about, right? My v6 pods right now run happy, but my services are not just, or at least from what I understand from the folks who are running services on containers, you're not just going directly to access the pod, right? You have to have like an ingress mechanism for your application, all that stuff. So how do we do that? We had the load balancer earlier for v4. Can I use the same?
Yes. So what happens in case of when you have an IPv6 cluster? These ELBs are dual stack. Basically, you say, I want to now provision a service or an ingress, and you say, in case of the ingress, it's an ELB, or in case of a service, it becomes an NLB. And you specify an annotation which we support called as a dual stack. So your ELBs are especially at dual stacks. You can come in from an IPv4 or you can come in from an IPv6, doesn't matter. The targets for those ELBs are always going to be an IPv6 target, right? In case of a ELB, it can be instance as well as an IP target, like how you have configured your service definition, depending on the annotations that you have added. And for NLB, it's IP targets that we support today, right? So the pod IPs that you see, IPv6 addresses, are registered as targets under the ELBs. Yeah, and everything behind these load balancer are always going to be IPv6. There is no IPv4, right? If it is IPv4, that traffic basically NLB does all of the, like these load balancer does all of the NATing functionality that is required really from an IPv4 to the backend IPv6.
Nice. Okay, so if I'm my EC2 instance here or whatever, my IPv4 service, IPv4, we're going to call it legacy because we heard this morning that we should start calling IPv4 legacy. So I'm going to call it my IPv4 legacy service. When this service wants to open a connection to my new service right now that runs on my EKS cluster that's on IPv6, it can do that, right? So it can do that because the load balancer is dual stack.
Yeah, because it's a dual stack, it has both like A records as well as a card A records that are created, right? So depending on where you're coming from, it gets resolved to one of those. And then the backend is going to be an IPv6 all the time.
Awesome. That's great. Okay, perfect. Cool. So this makes things very easy for me because I feel like it's the network that's not working. It's not going to be a problem with this. So let's see. We've talked about egress. We've talked about ingress. What else did we not talk about? What else should I be knowing?
I think the question about the control plane, right? So you create a cluster, you provide the subnets when you create the clusters. So what do we do? Your control plane is running within AWS, EKS managed VPC. And we kind of create in the backend what we call as cross-account ENIs. These are managed cross-account ENIs. And in an IPv6 scenario, when you create an IPv6 cluster, these cross-account ENIs receive both IPv4 as well as an IPv6 address. So I'll let you finish drawing it, and then we can talk about.
So my EKS control plane lives here in the Amazon VPC that's managed by EKS.
Yeah.
And when I create my cluster here, I have this fellow communicating to an XCNI here,
Correct.
XCNI. And I
And
have an XCNI here as well. It's one per subnet or for each worker node?
it's just for a subnet, and the subnets basically that you kind of pass while you create a cluster. Yeah, you can have your
Perfect.
nodes itself in a separate subnet, but we mandate you to at least specify 2 subnets across 2 AZs while you create a clusters. Those subnets can be smaller.
Got it.
Yeah, it's just used
Cool.
for your
Cool.
cluster creation and updates. Yeah.
So the CNI has, as you said, both an IPv4 address and an IPv6 address, right? So when I need to talk to the control plane, I can go through this XCNI, right?
Correct. Yeah. And the question like 2 IPv4 subnets, right? So when you are creating a cluster, the subnet that you specify have to be dual stack. It cannot be just an IPv4 subnet, because those XCNIs where we create in those subnets
To be dual
must
stack.
receive both IPv4 and IPv6. They must be dual stack itself. Just the EKS control plane, what you see, the API server, that's all IPv4 today. Yeah, it's not IPv6 yet.
Nice. Okay, perfect. Cool. Okay.
And she talked
So
question from the chat there about the same requirements are still apply, right, for how many subnets are being
Yeah.
given, even in a dual or IPv6 cluster. So
Yes. Yeah. That those requirements do not change. All of those fundamental prerequisites, the network prerequisites, still apply here. So what happens now? Like, the
one
pop.
thing, one thing before we jump in, there's a question here or a remark, more or less. Rudix World said that I asked previously, but before it's public IPs. I think if I understand it correctly. Let's clarify this one. We did talk a bit about it in the previous session. So if you're interested to watch the recording for that, we're going to have it on the routing loop page. But correct, your Amazon VPCs are going to have global unicast addresses. They are publicly routable, meaning you can choose to advertise them. You can also use multiple CIDRs, and you can choose which ones you want to advertise or which ones you don't want to advertise. So very important. I don't think we have the time right now to go super in depth into that, but we talked about it in our previous session. So please check out the routing loop page, and we're going to upload there the recordings.
And I know, Sheetal, you have a demo, right? Do we want to jump over and show people this in action?
Yeah, we
Yes.
will do that. It's not a super long demo, but I think the one thing that we want to close loop on here is basically when EKS control plane wants to talk to the pods or any like node agents that are running on our worker nodes like kubelet, kubeproxy, right? It's always an IPv6 of the XCNI, right? EKS makes a connection to the worker components via the XCNI using an IPv6 address. And kubelet and the kubeproxy, because they have to kind of also talk to the API server back, they, depending on how you have set up your cluster, whether it's public private, or a private, it takes a different route. If it is completely private, it might take an XCNI route, and still it's an IPv4. It's always routed. The reverse traffic is always an IPv4, because EKS control plane itself is still an IPv4 until that is completely becoming IPv6. Yeah.
It's pretty cool. So things are still going to be working. I think one more thing that I want us to clarify before we jump into the demo. I still have my 2 clusters. I have a v4 one and I have a v6 one. Is there a way, or how should I be thinking about migrating and like stopping my v4 one, because I don't want to manage 2 clusters, or in the case of where I have thousands, is that a lot of EKS clusters on v4? How do I get to clean them up and migrate my services to v6?
So
assuming I've tested all things on v6 and they work.
Yeah. And I guess you do not want to do a lift and shift completely. That's completely fine. You have a test IPv6 cluster and your applications are themselves IPv6 compliant and you have tested everything fine. Just go ahead, and there are multiple ways, right? Like you can do part by part, like you have few applications in an IPv4 because they cannot be still IPv6 ready because your application team said they need more time. So you just migrate some of the applications onto an IPv6 cluster. And probably in this scenario, you might be using cross, like some kind of service mesh, right? Whether it is like top of the shelf or your homegrown, doesn't matter. So you still want
You're
that.
using VPC lattice. You're using VPC lattice.
Yeah.
We're gonna have later, Justin.
Yeah, cross-cluster communications. So then you directly are communicating to a Kubernetes service. June 15th, please watch out for, we are going to be launching an egress v6 communication capability from within the IPv4 cluster. It's kind of one of the most requested ask from many of our customers. So they should still be able to kind of do like canary deployments, like lift part of it onto the IPv6 cluster and still leverage all of the cool service mesh capabilities across the cluster if they have a cross cluster service mesh set up today, right? That's a possibility. Or some of the customers, typically what they do is, because they do not have any dependency on the service meshes for communications, and the applications on an IPv6 cluster are always going to be accessed via some kind of ingress, right? Like through the load balancer, right? It's a easy migration in that way, right? You just create a load balancer, which is a dual stack. You can still access that dual stack load balancer from within your pods. That's another way to do it. Yeah. And just entry into the cluster itself, the same application is running in an IPv4 and an IPv6 world, and you kind of create two load balancers separately and then handle the traffic outside of the load balancer itself, right? Yeah, part of, just do like, yeah, shifting depending on how you are migrating and what's the nature of your application.
Yeah, and there was a super cool question there. Totally works if you have a dual stack load balancer and in a dual stack subnet, and you can continue to run your service on v4 in EKS. Yeah. So very important. There's the reason why you would want to move EKS to v6 is to actually help with that IPv4 exhaustion. But if by any chance you don't have problems with IPv4 exhaustion, then you can totally do the ingress layer on dual stack, because perhaps you have clients on v6 that need to access your service. And you can continue running your applications on v4. In our next session, we're actually going to be talking about adoption paths. So we're going to be talking about the internal first adoption path, external facing adoption path, and the different business drivers there.
Justin, you can bring my screen on the, yeah. Cool. So what I'm going to do, I'm just going to go ahead and create a cluster here. Simple, like the API itself remains same. Only thing that you would want to do is pass in the dual stack VPC. And when you create a cluster, you just specify, I want the cluster IP address family to be an IPv6, right? Everything else remains same. I have already created a cluster. I'm just going to jump on to the existing cluster for now. Yeah. So interesting to note, the subnet requirements same. I have 3 subnets across 3 AZs, 3 private and 3 public subnets. My VPC itself is a dual stack. And another thing that I think in the previous conversation that we missed is Kubernetes service IP. This IP range is, if you carefully observe here, it's not a VPC CIDR. It's not from the GUA range, right? It's from a unique local range, and just EKS picks it up for you, and you cannot change it after the fact that cluster is created. My cluster is public and private. So let's look at the VPC, nothing fancy.
And your cluster is also 125, just to point out that we've supported this for quite a while now. 127 is out, and so 127, 126, 125. I think any supported EKS version right now supports IPv6. So if you have an EKS cluster, you don't need to upgrade to get this.
Yeah, thanks, Justin, for pointing that out. So I'm on a node here, as we talked about, at node creation, an IPv6 prefix is assigned /80. along with an IPv6 address, the nodes also receive an IPv4 address, right? So rest, everything else kind of remains the same. Let's connect to this node. I just want to quickly take a look at the VPC configuration, VPC CNI configuration itself. Let's see if I have one open here. Okay, so as you see here, is the top section is the VPC CNI, like, whatever you have known previously. And within IPv6, there is an egress v4 only CNI that we kind of chain together. And what you see here is a subnet 169.254.172, which is a host local IPAM plugin that's used. Let me go ahead and connect to my cluster. I have already some applications running here. I'm just going to go ahead and run a sample demo app. What I have. So if you see the definition of the pod itself, there is no annotation. You do not specify a family as dual stack or an IPv6. It's just a simple plain specification, deployment specification. Just in the service, you might want to take a look at the different load balancer annotations that we support. What I'm saying here is this is my internet facing. I just provide a load balancer name and I say dual stack. Yeah, we do not support IPv6 only like annotation. It has to be a dual stack. By default, it's an IPv4, but it's on IPv6 cluster. You have to specify as a dual stack. It's an NLB, so I'm just specifying as an IP target. Let me go ahead and deploy this.
While you're doing that, there's a good question from Matt Henry. But if you do need to recreate a new VPC subnet, if you're not dual stack, right? No. So if you have a VPC that is IPv4 and your subnets are IPv4, you can add IPv6 on top of that. IPv6 CIDRs are secondary CIDRs on your VPC. So you can always retrofit existing VPCs to dual stack VPCs. What you do need to recreate is your EKS cluster itself to get it to on the IPv6 address family. That's all.
And there was also a really old question in chat that I was going to bring in, but we didn't get to it, about like how do I prepare my applications to be IPv6 ready in the cluster. And the main thing there is actually just to make sure that your whatever libraries you're using in your application support IPv6. I know there are plenty of older versions of Java and some other libraries that just don't have any awareness of IPv6. And as soon as they see an IPv6 address, it actually doesn't know how to route the traffic out if it wants to go IPv4 or 6. So you need to make sure your libraries are using your application. Are there anything else they should be considering for applications?
I don't think so. I think actually there is. If your application code is actually hard coded to do calls to IPv4 addresses, make sure you check that.
No one would ever do that. I don't understand. That's not. Sheetal's carrying on with the demo. I'm sorry, we were answering questions.
Yeah, no, I think we are fine. Justin, do you want to just paste this one on a comment? I'm not sure why it's not going on a comment when I do that.
I did already. So everyone, check IPv6-cluster-test kitv5.net. Click it.
I missed it. Where did you leave it in the chat? Oh, there it is. I see it. Let's pull that in.
So, yeah, the application that I just deployed, Nginx, it has created a load balancer, and we have a front-end domain that is forwarding it to the backend dual stack load balancer. Just go ahead and click it. So you'll see if you're coming in from an IPv4, you will see it get resolved to an IPv4. The server IP itself is a pod IP of the Nginx server that I have deployed. So it should all work. It's a dual stack NLB that's running that this domain is forwarding to. Let me go ahead. I just deployed a busy box.
I don't think it scaled up for me because it's not resolving on my end, but that's okay. I'll debug that later.
Try dig that one. Let's see if we get you.
I came into an Amazon office today, and I don't know what the networking's like here, so I have no idea if I.
Not good.
I'm inside like a busy box. I just exec into the busy box pod. So what you're seeing here is an IPv6 address, and along with that, so the IPv6 address for a pod, along with that 169.254, right? But when I'm curling just the NLB, it always leaves or takes in an IPv6 address. You will not ever see an IPv4 address that's going to be advertised out. I also have, I think I created an IPv4 an endpoint. So this is IPv4 only endpoint. So when you basically are trying to connect to an IPv4, so what you see here is the remote IP. It's not your pod IP, right? So the pod IP is 169.254, but it kind of leaves your worker node NATed to the primary IPv4 address. Because it's a primary subnet that the worker node is running, it is NATing to the NAT gateway EIP here. That's what we are seeing. So both IPv4 as well as an IPv6 egress connectivity just works fine from a pod.
It did work for me. I tried again.
Yeah.
Nice. Awesome.
I think we are
Very cool.
right on time. We pretty much covered everything that we wanted to cover today.
Awesome.
Awesome. Well, I want to take the chance to sort of restate one thing, which I think it's super important. One, thank you folks for having us today, for partnering with us on this AWS IPv6 day, and for helping a poor network engineer understand how EKS and containers networking works. I'm super thrilled about this. It's just recently I actually understood how things work, and I'm super excited about this. And the fact that EKS supports IPv6 and you can do this so easily without breaking your existing applications, without breaking your existing setup, is pretty impressive. I want to hear from all of you who joined us today. If you've tried this at home, like I'm gonna go create a new EKS cluster tomorrow to have it as demos for my customers whom I'm talking about networking stuff, just to show them how easy it is.
Yeah, and it just works. We do not have to worry whether IPv4 works for me, if I am IPv4 ready or not. I know from a network perspective, VPC, subnets, and bringing in an IPv6 it takes some thinking, but EKS just works out of the box. So go ahead and try it out and let us know your feedback or any other new features. Don't forget to go onto Containers Roadmap to leave your feedbacks.
Yes, if you like the show, we have a YouTube channel with a whole bunch of other content. We do regular streams here about anything containers, container related on AWS, Kubernetes, ECS, App Runner, all sorts of stuff. So that's the YouTube link right there. I've been making a ton of shorts if you like TikTok in short form. Those have been a lot of fun, but we do the regular streams here on Twitch and YouTube. So go check it out and subscribe if you like the content. And thank you so much for coming. This was a blast, and I learned a bunch because I always want to learn more about networking as well. So
Alex, thanks for bringing
you.
your cat and for this cat today.
Alex, what's next?
So next we have IPv6 adoption paths. We're gonna have Adi back with Tom, so stick on the channel. Don't go anywhere. They're gonna be live in like 30 seconds. They're going to be talking about the adoption paths. Where should you start, right? Should I start within my VPC? Should I start at the edge? Should I start with my CloudFront distribution? Where should I start, right? And what are the benefits from the business perspective? Because this is one of the biggest questions that we're getting all the time. Like, what is the business benefit of this, right? So very important. And stick around, because after that, we're going to have our first customer, Netflix, joining us. Customer and partner. We're closely working with the folks on the Netflix side on all things IPv6. They're one of the customers who've helped us a lot. And then we're going to have Infor, another great customer who is working closely with us on all these features that we've launched over the years. So thank you so much. Don't go anywhere. 30 seconds, and Tom is going to be back live. Thank you.
All right. Thank you so much.
Yeah. Bye. Thanks.